Okay, so in 2-2 we are looking at linear relationships. So we're switching over, and this part of the chapter we're going to be looking at equations of lines and reviewing all of those. So what we're going to do is start by talking about what an equation of a line looks like. Okay, so some of these are lines and some of these are not lines, so they're curves or something like that. Okay, so a line can be written in this format. Okay, now y is the same thing as writing f of x. But the equation of the line itself has a number here and a number here. Okay, so that would be what a line would look like. So looking at that first one over there, f of x equals, would that be able to be written as mx plus b? I'm seeing yeses and nos. Well, one of them's right. Those of you that say yes, how could you write this as mx plus b? I agree with this. Okay, what's another way to write x over 5? What's another way to write x divided by 5? 1/5 x. Okay, that's the same thing as x over 5. So is that in mx plus b form? Yes. Okay, so this is yes. Okay, next one. Looks pretty similar. Could we do the same thing? What would it look like if we did the exact same thing? Nope. What would this one be? It'd just be x over x, which is 1. Is this mx plus b? No. Okay, this x in the denominator makes it a no. So on the homework, when you're saying your yeses and nos, if it's a no, tell me what makes it no. Okay, but if it's yes, you can just say yes. Okay, this one. We don't have to rewrite this one. Is this one yes or no? I'm hearing yes and no. This one's a no. Why is it no? Yes. Okay, does anyone know what type of graph this would end up being if you did graph it? It is a parabola. Okay, we're going to get to that later in the year. Okay, it looks like a U. Okay, so that would look like that. All right, this next one. Is this one linear? Yes, this one already is in slope-intercept form. Okay, so that one's yes. Questions on that part? I'm going to do the same thing on the test. Okay, next is standard form. All right, so we need to write each of these in standard form. Here's what standard form looks like. Ax plus by equals c. Okay, now here's some rules with these coefficients. They all have to be integers. Okay, so that means no what? What things aren't allowed if they have to be integers? Fractions, decimals, okay? Can there be positives and negatives if they're integers? Yes, okay. A has to be positive. Those are the rules. Okay, so we're going to do these. So we have to get x and y on one side. So on this one, these first two are in slope-intercept form, so we're going to take them out of slope-intercept form, put them into standard form. Okay, so that's part of your answer, writing the equation. And then they want you to list A, B, and C. Okay, so what's A? What's B? 1. And C? -7. Okay. Next one. Move the 6x. Okay, now remember the rules over there. A has to be positive. So what do we do to this one? Okay, you can either divide or multiply by -1. So now we get this answer. So we got 6, -1, -5 for our three numbers. All right, and then this last one. Okay, we've got lots of fractions. We're going to multiply every single term, so there's 4 terms there, including the 0. We're going to multiply it by a magical number that will get rid of all of the fractions. What number is that? 12 would be a great number. Why? Okay, it would be the common denominator between all of those numbers, 3, 4, and 6. Okay, so we're going to multiply everything by 12. Here's what's really happening. You're multiplying by 12 over 1. Do you need a common denominator when you multiply fractions? No. Okay, we're just going to multiply straight across. So we're going to distribute this 12 over 1 to all 4 terms. So if we multiply straight across, we now have 24 over 3y minus 36 over 4x plus 12 over 6 equals still 0. 12 over 1 times 0 is still 0. Now we can simplify this. So this is really now 8y minus 9x plus 2 equals 0. No more fractions. Okay, we need to move this 2, and we also need to rearrange these over here. So I'm going to do that in the same step. So now we've got negative 9x plus 8y equals -2. We're almost there. We have to do what we did on the last problem. We have to make this 9 a positive. So divide everything by -1 so that we can get our 3 numbers. Questions on that part of the homework? There's only one example problem left. Are you ready for that last slide? Okay. So the last thing is X and Y intercepts. Okay, so let's think about this. We want to find the X-intercept. What's another way to say X-intercept if you were going to describe it to somebody? What's a way to kind of make it not sound so math-like? If you were going to describe, yeah, where it crosses the x-axis or that horizontal line, okay? What's in common with all of these points along the x-axis? What's 0? So all of these points along the x-axis here, I'm hearing multiple answers, so that's why I'm saying it again. What is in common with all of these blue points? Do we agree? Is the y value 0 right here? Is the y value 0 right here? Okay, so to find this x-intercept, here's how you do it. You make y equal to 0, and you solve. So we do the exact opposite to find the y-intercept. Where it crosses the y-axis, we make x equals 0. Okay, so let's do this here. So to find the x-intercept, we're going to make y 0. So we've got 2x plus 3 times 0 equals 12, which is really 2x equals 12. We get 6. Okay, so on the x-axis, we know it's going to cross through right here. Okay, the line has to go through that point. Now we can find the y-intercept, okay, which is doing the exact opposite. We make the x equal to 0. Okay, which is really 3y equals 12, giving us 4. So on the y-axis, we know the line has to go through that point. So now to draw the line, all you do is connect those 2 points. Okay, so we got the x-intercept, the y-intercept, and then you connect them. And that's what the last set of problems is going to look like. Questions on that part?